Welcome to ScienceCover.com. In this session, we will look at momentum. The aims of the session are to study what we mean by momentum, to perform momentum calculations, and to be able to rearrange the equation to calculate velocity and mass. Before we begin, pause the video and attempt the do now task. Let's check our answers. What is the stopping distance? The stopping distance is the thinking distance plus the braking distance. What is the thinking distance? This is the distance the car travels and the time taken for the driver to react to the situation. What factors influence the thinking distance? This could be the age of the driver, tiredness, alcohol or drug use, distractions such as a phone, music or satellite navigation device. What is the braking distance? This is the distance travelled by the car between when the brake pedal is pushed and when the car comes to a stop. What factors influence the braking distance? This could be the speed of the vehicle, the mass of the vehicle, the number of passengers or the luggage, the maintenance of the vehicle, so that could be the tyre tread depth or the brake pads, the surface of the road, or the weather conditions. Now let's look at momentum. Momentum is a property of mass and speed combined. It can be thought of as how difficult it is to bring an object to a stop. These two basketballs have the same mass, but one basketball is moving at 14 meters per second while the other is moving at 7 meters per second. This means that the top basketball has more momentum. It's more difficult to stop as it has more speed. However, in this case, we have a bowling ball and a basketball, and the mass of the bowling ball is greater than the mass of the basketball. So despite the fact that the basketball is moving at 14 meters per second and the bowling ball is only moving at 7 meters per second, in this case, it'll be the bowling ball that has more momentum. That is because the bowling ball is more difficult to stop, and this is because it has more mass. Momentum is measured using the units kilogram meters per second. This is a combination of the units of mass and speed. This truck and car are travelling at the same speed, 10 meters per second. But the truck has a much higher mass than the car. This means that the truck has more momentum at the same speed. Therefore, it has a longer stopping distance. This is why that the speed limit for cars on motorways is 70 miles per hour, whereas the speed limit for a lorry on the motorway is 60 miles per hour. Pause the video now and complete task 1. Let's check our answers. Number 1, what two factors are used to determine an object's momentum? That's mass and velocity. What are the units of momentum? Kilogram meters per second. A car, a motorbike and a lorry are travelling at the same speed on a motorway. Which will have the largest stopping distance and why? This should be the lorry as it has more mass. Which will have the shortest stopping distance and why? That will be the motorbike as it has less mass. The motorbike increases its speed to overtake the car. What will happen to the momentum of the motorbike and why? The momentum increases as the speed increases. What will happen to the stopping distance of the motorbike? This will increase. And why is the speed limit different for a car and a lorry? This is because the lorry has a larger mass and therefore has a larger stopping distance. The speed limit is lower for the lorry to lower the stopping distance. Now let's look at how we can perform calculations using the momentum equation. Momentum can be calculated using the equation momentum is equal to mass multiplied by velocity. We can use the symbol P to represent momentum, M to represent mass, and V to represent velocity. So we can say P is equal to M multiplied by V. Let's look at an example. An aeroplane of 20,000 kilograms is flying at a speed of 250 meters per second. What is the momentum of the aeroplane? So to work out the momentum, I'm going to take the mass and multiply by the velocity. I'll substitute in my numbers, 20,000 multiplied by 250. And this tells me that the answer is 5 million. And the units for momentum are kilogram meters per second. Let's look at another example. A garbage truck has a mass of 29,000 kilograms. It moves down the street at 0.5 meters per second. Calculate its momentum. So again, we'll use the equation momentum is mass multiplied by velocity. We'll substitute in our numbers, 29,000 for the mass and 0.5 as the velocity. This gives us an answer of 14,500 and the units for momentum are kilogram meters per second. Pause the video now and complete task 2. Let's check our answers. Number 1. A man has a mass of 70 kilograms and runs at 3 meters per second. Calculate the man's momentum. So we do 70 multiplied by 3, which is 210 kilogram meters per second. A mouse has a mass of 0.5 kilograms and runs at a speed of 5 meters per second. Calculate the mouse's momentum. So this is 0.5 multiplied by 5, which is 2.5 kilogram meters per second. A child has a mass of 50 kilograms and runs at 6 meters per second. Child B has a mass of 40 kilograms and runs at 7 meters per second. Calculate the momentum of child A. So we do 50 times 6, which is 300 kilogram meters per second. Calculate the momentum of child B. So this is 40 times 7, which is 280 kilogram meters per second. Which child has the larger momentum? That would be child A. Which child would win if they were in a race? This would be child B. Ball A has a mass of 0.5 kilograms and is thrown at 4 meters per second. Ball B has a mass of 0.7 kilograms and is thrown at 3 meters per second. Which ball is moving fastest? That would be ball A. Which ball has most mass? That would be ball B. Which ball has the most momentum? Well, if we calculate the momentum, ball A is 2.0 kilogram meters per second, and for ball B, we get 2.1 kilogram meters per second. So ball B has the larger momentum. Question 5. The diagrams show information on 4 types of transport. Calculate the momentum of the lorry first of all. It should be 28,000 kilogram meters per second. The car is 12,000 kilogram meters per second. The bike should be 7,500 kilogram meters per second. And the horse should be 5,500 kilogram meters per second. Now let's look at how we can rearrange the equation. We can place the momentum equation into an equation triangle, with momentum on the top and mass and velocity at the bottom. Now we can work out the three forms of rearranging the equation by covering up what we want to find. So starting with what we've already done, we know that momentum is equal to mass multiplied by velocity. If we want to find mass, then we can cover up mass, and this tells us that it's momentum divided by velocity. Now if I want to find the velocity, I cover up velocity, and it tells me that it's the momentum divided by the mass. Let's look at an example. What is the mass of a train that has a momentum of 30,000 kg/s if it's travelling at 5 meters per second? So I want the mass. So the mass is the momentum divided by the velocity. If I substitute in the numbers, that's 30,000 divided by 5, which gives me an answer of 6,000, and since it's mass, the unit is kilograms. What is the velocity of a 50,000 kilogram tank if it has a momentum of 300,000 kilograms? So we want the velocity this time, so that's momentum divided by mass. Substituting in the values, so we get 300,000 divided by 50,000, which is equal to 6, and the units for velocity are meters per second. Pause the video now and complete task 3. Let's check our answers. Number 1, the table shows information on 3 moving animals, and you have to calculate their mass. So the giraffe has a mass of 17,600 kilograms, the hippopotamus has a mass of 7,200 kilograms, and the bison should have a mass of 20,000 kilograms. Question 2. 3 horses compete in a race. Which horse has the fastest speed? Well, if we calculate the velocity of each of the horses, we find horse A has a speed of 5 meters per second, horse B has a speed of 6 meters per second, and horse C has a speed of 5 meters per second, which means that horse B is the fastest speed. The jockeys must jump a series of fences with their horses as the race progresses. Which horse is most at risk of injury if it hits a fence, and why? Well, this will be horse B, as it is the horse with the largest momentum. An impact with high momentum is most likely to cause harm.